I am MS Devi Mani, working as an assistant professor in the Department of Mathematics, Erode Engineering College, Perundurai. Now we are going to see the chapter vector calculus. In this vector calculus, first we are see what is vector differentiation. That is here the first one is gradient. In gradient we have first the vector differential operator. The vector differential operator is denoted by reverse del, that is defined by I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. Here the vectors I vector, j vector and k vector are the unit vectors along the three rectangular axes ox, oy and oz. It is called Hamiltonian operator, and it is neither a vector nor a scalar, but it behaves like a vector. Next we see the gradient of a scalar function. Here scalar function is pi, that is pi of x, y, z is a scalar point function. This scalar point function is continuously differentiable in the given region of space. Then the gradient of pi is defined as del pi equal to, that is already we know del is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into this scalar point function, that is del pi equal to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. It is del pi, that is reverse del pi, that is the gradient of a scalar function. We also read it is grade pi. Here now we are going to see some important note. First one is this del pi is a vector quantity. Then if del pi is 0, then pi is a constant, that is the scalar point function is constant, then we always have the gradient of pi is 0. Then del of pi 1 into pi 2 equal to pi 1 into del pi 2 plus pi 2 into del pi 1. That is del of pi 1 into pi 2 equal to, here the multiplication property, that is pi del of pi 1 into pi 2 equal to pi 1 into del pi 2, then we take pi 2 as constant into del pi 1. The same way del of pi 1 by divided by pi 2 equal to pi 2 into del pi 1 minus pi 1 into del pi 2 divided by pi 2 square. Here pi 2 is always not equal to 0. Then del of pi plus or minus x equal to del pi plus or minus del x. Now we are going to see the problem. First we find that is gradient of pi, where pi is a scalar point function that is given by 3x square y minus y square z square at the given point 1 comma minus 2 comma 1. Already we know that del, that is reverse del equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. This is reverse del, that is this del of pi. Here pi is given that 3x square y minus y cube z square. That is I vector into del pi is I vector into this I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. Then from pi we find dou pi by dou x. Differentiating this pi with respect to x, we have here y is constant and now 3 is constant. Differentiating x square we have 2x, so 6xy. In the same way dou pi by dou y is here dou pi by dou y is 3x square minus 3y square z square. Dou pi by dou z is minus 2y square minus 2y cube z. Then now we substitute the values of dou pi by dou x, dou pi by dou y and dou pi by dou z in this formula, that is I vector into dou pi by dou x is 6xy plus j vector into dou pi by dou y is 3x square y minus 3y square z square minus k vector into dou pi by dou z. That is then we find the value of del pi at the given point 1 comma minus 2 comma 1. Substitute x equal to 1, y equal to minus 2, z equal to 1. We have that is I vector into 6 into x value is 1, y value is minus 2, that is 6 into 1 into minus 2, we have minus 12 I vector. The same way here minus 9 j vector plus 16 k vector. This is grade pi. If the scalar point function pi is given, then we find del pi. The same way here, given that pi equal to log of x square plus y square plus z square, then find del pi. We know the formula for del pi, that is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. From this pi we find dou pi by dou x, that is given pi equal to log of x square plus y square plus z square. From this dou pi by dou x equal to differentiating pi with respect to x. We know that differentiating logarithmic term we have, that is 1 divided by x square plus y square plus z square into, again differentiate this with respect to x, we have 2x. So dou pi by dou x is 2x divided by x square plus y square plus z square. In the same way we find dou pi by dou y is, that is instead of x here we have y, that is 2y divided by x square plus y square plus z square. Then dou pi by dou z is also 2z, instead of y here we have 2z divided by x square plus y square plus z square. Then we substitute all these values in this formula, that is I vector into dou pi by dou x value plus j vector into dou pi by dou y plus k vector into dou pi by dou z. That is, here all the terms we have, the common term is 2 divided by x square plus y square plus z square, taking this as outside. Here remaining x into I vector plus y into j vector plus z into k vector, that is 2 divided by, we know that r vector is the position vector, that is r vector equal to that is r vector equal to x I vector plus y j vector plus z k vector. From this determinant of r vector equal to that is determinant of x I vector plus y j vector plus z k vector, that is determinant of r vector equal to r equal to this determinant of x I vector plus y j vector plus z k vector, that is equal to root of x square plus y square plus z square. This is r equal to root of x square plus y square plus z square. From this r square equal to x square plus y square plus z square. So here we have 2 by r square into r vector. Okay, next one. Next example is find del of r and del of 1 by r and del of log r. Here given that r equal to determinant of r vector and also r vector is xi vector plus yj vector plus zk vector. That is from this we find del of r and del of 1 by r and del of log r. We know that determinant of r vector equal to r equal to square root of x square plus y square plus z square. From this we have r square equal to x square plus y square plus z square. Differentiating this r with respect to x, we have 2r into dou r by dou x equal to 2x. Then in the same way differentiating this with respect to y, we have 2r into dou r by dou y equal to 2y. Then differentiating with respect to z, we have 2r into dou r by dou z equal to 2z. From this dou r by dou x is x by r. This two getting cancelled. The remaining dou r by dou x equal to x divided by r, and also dou r by dou y equal to y by r, dou r by dou z equal to z by r. Then we know del of r equal to I vector into, since del equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z, del of r equal to I vector into dou r by dou x plus j vector into dou r by dou y plus k vector into the problem in the topic of directional derivative. Here, the first problem is find the directional derivative of pi equal to 4x square plus x square y z at this point 1 comma minus 2 comma 1 in the direction of 2i vector minus j vector plus 2k vector. That is, we know that the directional derivative equal to del pi into a vector divided by determinant of a vector. So we first del pi. Here a vector is the direction. Direction is I vector minus j vector plus j vector minus 2k vector. First from this pi we find del pi. We know that the formula for del pi is I vector into dou pi by dou x plus j vector into dou pi by dou y plus a vector into dou pi by dou z. From this pi we find dou pi by dou x. Dou pi by dou x is 4 z square plus 2xyz into I vector plus in the same way dou pi by dou y is, in this first term there is no y, so differentiating this with respect to y we have 0. In this second term, differentiate with respect to y we have this y will become 1, the remaining is x square z, so x square z into j vector. Then now we differentiate this y with respect to z, we have 4x into 2z, that is 8xz plus x square y. So x square y plus 8xz into k vector. This is the value of del pi. Now we find del pi at this given point 1 comma minus 2 comma 1. That is, we substitute x equal to 1, y equal to minus 2, z equal to 1. So del pi at this point 1 comma minus 2 comma minus 1 is 8i vector minus j vector minus 10k vector. Then a vector is given, that is a vector equal to 2i vector minus j vector minus 2k vector. From this a vector we find determinant of a vector, that is equal to square root of 2 square plus minus 1 square plus minus 2 square, that is root of 4 plus 1 plus 4, that is equal to root 9. Root 9 is 3. So determinant of a vector is 3. Now we substitute all these values in the given formula, that is del pi value, a vector value, determinant of a vector value. That is 8i vector minus j vector minus 10k vector into 2i vector minus j vector minus 2k vector divided by 3. Now we multiply these two, del pi into a vector. That is, here we have dot product. So I vector dot I vector is 1. The remaining 8 into 2 16. 16 plus here j vector dot j vector is 1, minus 1 into minus 1 plus 1 plus here k vector dot k vector is 1, the remaining is minus 10 into minus 2, that is plus 20. So 16 plus 1 plus 20, that is 37 divided by determinant of a vector is 3, that is 37 by 3. So if the scalar point function pi is given, from this we find the directional derivative, and also here the direction a vector is given, the point is given. From this we find directional derivative. From this formula del pi into a vector by determinant of a vector. The next problem is the same way we find the directional derivative using the formula. Here pi is xy square plus yz cube. Here the point is 2 comma minus 1 comma 1 in the direction of p cube, where q is the point 3 comma 1 comma 3. From this pi we find del pi using the formula I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. From this pi we find dou pi by dou x, that is y square. So y square I vector, then dou pi by dou y is 2xy plus z cube, 2xy plus z cube j vector. Dou pi by dou z is, here there is no z10, so differentiating this with respect to z we have 0. The second term is 3y z square, 3y z square into k vector. Now we find del pi at the given point 2 comma minus 1 comma 1. This 2 is for x, minus 1 is for y, 1 is for z. So we have I vector minus 3j vector minus 3k vector. Given A vector is PQ vector, that is PQ vector is known as OQ vector minus OP vector. That is OQ vector is 3I vector plus j vector plus 3k vector minus OP vector is 2I vector minus j vector plus k vector. Subtracting this from 3I vector plus j vector plus 3k vector, we have I vector plus 2j vector plus 2k vector. This is the A vector. From this A vector we find determinant of A vector, that is square root of 1 square plus 2 square plus 2 square, that is equal to square root of 9, that is equal to 3. Here the formula for directional derivative is del pi into A vector by determinant of A vector. Now we have the answer for del pi is I vector minus 3j vector minus 3k vector into A vector is I vector plus 2j vector plus 2k vector divided by determinant of A vector is 3. Now we multiply these two, that is del pi into A vector, we have 1 minus 6 divided by determinant of A vector is 3, that is minus 7 by 3. The next one is in what direction from minus 1 comma 1 comma 2 is the directional derivative of pi equal to xy square z cube a maximum. Find also magnitude of this maximum. Now here we find the direction, that is A vector. Here pi is also given, the point is given minus 1 comma 1 comma 2. Here given pi equal to xy square z cube. From this del pi is that is I vector into y square z cube plus j vector into 2xy z cube plus k vector into 3xy square z square. Here the point is also given, that is minus 1 comma 1 comma 2, that is x comma y comma z. Now we substitute these points in del pi. We have 8I vector minus 16j vector minus 12k vector. From this del pi we find the maximum directional derivative. The maximum directional derivative, that is the magnitude of this maximum directional derivative. This is the maximum directional derivative. From this we find the magnitude of this maximum directional derivative. The magnitude is determinant of del pi. That is we take the square root of this del pi. That is square root of x square plus minus 16 square plus minus 12 square. Here the answer is square root of 464. If pi is given, then we find del pi, that is maximum directional derivative. From this maximum directional derivative, we find magnitude of this maximum directional derivative. Then the next question is find the directional derivative of the scalar function pi equal to x, y, z in the direction of the outer normal to the surface z equal to x, y at the point 3, 1, 3. In all the problem, if pi is given, that is scalar point function, pi is given, we find del pi using this formula. This is the del pi formula. Here we want dou pi by dou x, dou pi by dou y and dou pi by dou z. We find all these three values, substitute, and del pi equal to I vector into yz plus j vector into xz plus k vector into xy. Then we find del pi at this given point 3, 1, 3. Here we have y is 1, z is 3, so 3 I vector plus x is 3, z is 3, so 3 into 3, 9j vector plus k vector into x equal to 3, y equal to 1, so 3k vector. This is the del pi. Now here given the given surface is z equal to xy. From this we have z minus xy equal to 0. From this formula del pi, here we have del x. We replace pi by x, we have I vector into dou x by dou x plus j vector into dou x by dou y plus k vector into dou x by dou z. So we find dou x by dou x is minus y, dou x by dou y is minus x, dou x by dou z is 1. Then we take A vector is this del x at the given point 3, 1, comma. Here the given surface is z equal to xy. From this z minus xy equal to 0, we take this z minus xy equal to capital X. So capital X equal to z minus xy. Now we find del x. We know del phi is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. Now we want del x. So replace pi by capital X. So del x equal to I vector into dou x by dou capital X by dou small x plus j vector into dou x by dou y plus k vector into dou x by dou z. From this x we find dou capital X by dou small x equal to that is minus y. In the same way, dou x by dou y equal to minus x, dou x by dou z equal to 1. Now we substitute all these values here, that is I vector into minus y plus j vector into minus x plus k vector into 1. Now here we want direction, so we take A vector equal to del x at the point 3, 1, 3. That is here y is 1, x is 3, z is 3. Here minus 1 into I vector, that is minus I vector. Here x is 3, so minus 3 j vector. Here there is no z term, so we have plus k vector. Now we have A vector is A vector equal to minus I vector minus 3j vector plus k vector. From this A vector we find determinant of A vector. Determinant of A vector equal to square root of this minus 1 the whole square plus minus 3 the whole square plus 1 square. So determinant of A vector equal to square root of 1 plus 9 plus 1, that is root of 11. We know that the formula for directional derivative is del pi into A vector by determinant of A vector. Already we find del pi is 3I vector plus j plus 9j vector plus 3k vector into here A vector is minus I vector minus 3j vector plus k vector divided by determinant of A vector is root 11. Now we find determinant of A vector is root 11. We substitute all these values in the given formula. Now we multiply these two, that is del pi into A vector. Here we have I vector dot I vector is 1. The remaining is 3 into minus 1 minus 3 plus this j vector dot j vector is 1. The remaining 9 into minus 3 minus 27. In the same way, k vector dot k vector is 1. Remaining 3 into 1, 3. Divided by determinant of A vector is root 11. Here minus 30 plus 3, that is minus 27 divided by root 11. The next problem is find the directional derivative of pi equal to xy plus yz plus zx at the point 1, 2, 0. The direction of A vector plus 2j, I vector plus 2j vector plus 2k vector. Also find its maximum value. Here scalar point function pi is given, that is pi equal to xy plus yz plus zx. From this pi we find del pi using the same formula, del pi formula. Dou pi by dou x is y plus z, dou pi by dou y is x plus y, dou pi by dou z is y plus x. Now we find del pi at this given point 1, 2, 0, that is here x equal to 1, y equal to 2, z equal to 0. So here y plus z, we have 2 plus 0, 2 I vector plus j vector into x plus z. X plus z is 1 plus 0, we have 1, so 1 into j vector plus y plus x, 2 plus 1, and it is 3k vector. This is del pi at the given point 1, 2, 0. In this problem, the direction is also given, that is A vector is given. A vector is I vector plus 2j vector plus 2k vector. Then determinant of A vector equal to square root of 1 plus 4 plus 4, that is equal to root of 9, that is root 9 equal to 3. Now we know the formula for directional derivative is directional derivative equal to del pi into a vector by determinant of a vector. We find del pi is 2i vector plus j vector plus 3k vector into, that is we have dot product. A vector is given I vector plus 2j vector plus 2k vector. From this a vector we find determinant of a vector is 3. Now we multiply this del pi into a vector, we have the answer is 10 divided by determinant of a vector is 3, 10 by 3. From this we find maximum value. We know that the maximum value is determinant of del pi. So determinant of del pi means here square root of 2 square plus 1 square plus 3 square, that is square root of 4 plus 1 plus 9, we have the answer is root 14. If the scalar point function pi is given and direction is also given, then we find directional derivative and also maximum value. Then the next topic is unit normal vector to the given surface. We take pi is a scalar point function, then pi of x comma y comma z equal to c represents a surface. Surface and the unit normal vector to the given surface pi is n cap equal to del pi by determinant of del pi. Always we denote the unit normal vector by n cap, that is equal to del pi, that is we know that pi is a scalar point function. From this we find del pi, from this del pi we find determinant of del pi. So del pi divided by determinant of del pi is known as unit normal vector. That unit normal vector is denoted by n cap. Now we see problem based on this unit normal vector. Here the question is find the unit normal vector to the surface x square plus y square equal to z at the point 1 comma minus 2 comma 5. Here the surface is the scalar point function, that is pi. So we take pi equal to x square plus y square minus z. From this pi we find del pi. Already we know that the formula for del pi. The formula for del pi is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. From this pi we find dou pi by dou x is 2x, dou pi by dou y is 2y, dou pi by dou z is minus 1. So we substitute all these three values here. We have 2x I vector plus 2y j vector minus k vector. Now we find del pi at the given point, that is x comma y comma z is given. We substitute all these values in this del pi. We have del pi is 2i vector minus 4j vector minus k vector. From this del pi we find determinant of del pi, that is equal to square root of 2 square plus 16, 4 square is 16 plus 1, and that is equal to square root of 21. Now we substitute del pi and determinant of del pi, both values in this formula n cap equal to del pi by determinant of del pi, that is 2i vector minus 4j vector minus k vector by square root of 21. The second problem is also related to unit normal vector. Here find unit normal vector to the surface x square plus xy plus y square plus xyz at the point 1 comma minus 2 comma 1. Here we take the surface is pi. This is pi. Pi equal to x square plus xy plus y square plus xyz. From this pi we find del pi. Del pi equal to I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. That is equal to I vector into dou pi by dou x is 2x plus y plus yz. Then from this dou pi by dou y is x plus 2y plus xz. Then dou pi by dou z is here all these three terms we have, there is no z term. Differentiating this term with respect to z we have xy. So k vector into xy. Now we find del pi at 1 comma minus 2 comma 1. We have minus 2i vector minus 2j vector minus 2k vector. From this, determinant of del phi is root 12. We write root 12 as 2 into root 3. We know that unit normal vector n cap equal to del phi by determinant of del phi, that is equal to minus 2i vector minus 2j vector minus 2k vector divided by 2 into root 3. Here all the terms minus 2 is common. That is, we take minus 2 as outside. Minus 2 into I vector plus j vector plus k vector divided by 2 into root 3. Now this 2 getting cancelled. The remaining is minus 1 by root 3 into I vector plus j vector plus k vector. Here r square equal to x square plus y square plus z square. Differentiating this r square with respect to x, we have 2r into r by dou x equal to 2x. In the same way, differentiating this r square with respect to y, we have 2r into dou r by dou y equal to 2y. Then differentiating with respect to z, we have 2r into dou r by dou z equal to 2z. From this, here this 2 getting cancelled. Then dou r by dou x equal to x by r, dou r by dou y equal to y by r, dou r by dou z equal to z by r. From this, we find del of r. We know that the formula for del of r is I vector into dou r by dou x plus j vector into dou r by dou y plus k vector into dou r by dou z. That is, I vector into dou r by dou x is x by r plus j vector into dou r by dou y is y by r plus k vector into dou r by dou z is z by r. In all the terms, 1 by r is common, so we are taking outside. Here 1 by r into xi vector plus yj vector plus zk vector. That is 1 by r into this is r vector. So del of r equal to r vector by r. Next we find del of 1 by r. We know that the formula for del is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. Now we find del of 1 by r. That is, I vector into dou by dou x of 1 by r plus j vector into dou by dou y of 1 by r plus k vector into dou by dou z of 1 by r. Now differentiate this 1 by r with respect to x. We have I vector into differentiating 1 by r, that is minus 1 by r square into dou r by dou x plus j vector into differentiating 1 by r with respect to y. We have minus 1 by r square into dou r by dou y plus k vector into differentiating 1 by r with respect to z. We have minus 1 by r square into dou r by dou z. In all the terms, minus 1 by r square is common, taking outside. So minus 1 by r square into the remaining is I vector into this dou r by dou x is x by r plus j vector into this dou r by dou y is y by r plus k vector into this dou r by dou z is z by r. That is equal to, in the same way here in all the terms 1 by r is common, so taking outside, that is minus 1 by r square into 1 by r. The remaining is xi vector plus yj vector plus zk vector. So minus 1 by r cube into r vector. Therefore del of 1 by r is minus r vector by r cube. In the same way we find del of log r. Del of log r is, that is, we know that del is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. We write this del as summation I vector into dou by dou x, that is equal to summation I vector into dou by dou x. So summation I vector into dou by dou x of log r. Differentiating log r with respect to x, we have 1 by r into dou r by dou x, that is 1 by r into the formula for dou r by dou x is x by r. So summation I vector into x by r square. Now we expand the summation. We have that is equal to I vector into x by r square plus j vector into y by r square plus k vector into z by r square. So in all the terms 1 by r square is common. Taking 1 by r square as outside, the remaining is xi vector plus yj vector plus zk vector, that is equal to 1 by r square into r vector. Therefore del of log r equal to r vector by r square. Next example is, we have to prove that del of r power n equal to n into r power n minus 2 into r vector. Here also we are using r vector equal to xi vector plus yj vector plus zk vector. Now we find del of r power n. We know that del is vector differential operator, that is I vector into dou by dou x of r power n plus j vector into dou by dou y of r power n plus k vector into dou by dou z of r power n. That is, now differentiate this r power n with respect to x. We have n into r power n minus 1 into, again differentiate this r with respect to x. So dou r by dou x. The same way, differentiating r power n with respect to y, we have n into r power n minus 1 into dou r by dou y plus k vector into, differentiate r power n with respect to z, we have n into r power n minus 1 into dou r by dou z. Already we know that dou r by dou x is x by r, dou r by dou y is y by r, dou r by dou z is z by r. So in all the terms n into r power n minus 1 is common. We take n into r power n minus 1 as outside. The remaining is x into I vector into x by r plus j vector into y by r plus k vector into z by r. Here also we have 1 by r is common. So n into r power n minus 1 into 1 by r into xi vector plus yj vector plus zk vector. That is equal to n into r power n minus 1. We write 1 by r as r power minus 1 into, this is r vector, that is equal to, here the base is same, so we add the power, here n minus 1, here minus 1, so n into r power n minus 2 into r vector. Therefore del of r power n equal to n into r power n minus 2 into r vector. Next here given that pi, that is scalar potential is given, we find determinant of del pi. From this pi, first we find del pi. We know that the formula for del pi is I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. From this pi, first we find dou pi by dou x. Differentiating this pi with respect to x, here we have the first term 2x z power 4 becomes 2z power 4 minus differentiating x square y with respect to x, we have 2xy. That is dou pi by dou x is 2z power 4 minus 2xy. Differentiating this with respect to y, we have in this first term there is no y, so differentiating this we have 0. The second term this y will become 1, remaining minus x square. So j vector into minus x square. Then differentiating this pi with respect to z, we have here 2x is constant, differentiating z power 4, we have 4z cube. So 2x into 4z cube is 8xz cube. Here there is no z term. Differentiating this we have 0. So this is dou pi by dou x, dou pi by dou y, dou pi by dou z. Differentiating all these values in the given formula, we have I vector into 2z power 4 minus 2xy plus j vector into minus x square plus k vector into 8xz cube. Now we find del pi at this point 2 comma minus 2 comma minus 1. We substitute z equal to minus 1, x equal to 2, y equal to minus 2. Simplifying this, we have 10 I vector minus 4j vector minus 16k vector. From this we find determinant of del pi, that is square root of 10 square plus minus 4 the whole square plus minus 16 the whole square, that is equal to square root of 100 plus 16 plus 256, that is equal to square root of 372. So if pi is given, from this pi we find del pi using this del pi formula. Next one is directional derivative. We find directional derivative of a scalar point function. This is the formula for directional derivative. That is directional derivative equal to del pi into a vector by determinant of a vector. Here a vector is the direction of a scalar point function. Here the maximum directional derivative is determinant of del pi or determinant of grade pi. Now we see problem using this directional derivative formula. The problem is find the directional derivative of pi equal to 4x z square plus x square y